San Diego's Bataquitos Lagoon sits right beside one of the region's busiest highways, Interstate 5. But it's the gently swaying stalks of cattails that have captured the interest of two researchers at the Salk Institute for Biological Studies.
So you can see how hard it is to dig out. That's why it really holds the sediment extremely well.
Joseph Noel watches his colleague Todd Michael use a small hand shovel to cut into the dirt around the base of a cattail stem. Michael lifts up a newly liberated plant.
This is an example. It's still alive, so you can see a new shoot is forming.
The plant's roots are coated in a sticky black mud. The rich, wet dirt is created by the constant push and pull of this coastal wetland environment. Michael says saltwater regularly flows into the estuary, pushing back and even killing the freshwater cattails. The ones that replace them grow over the dead, and that creates the sediment.
So this is the rhizome. It's hard to see because it's all muddy.
The rhizome is an underground stem that grows sideways, much like the roots of grass found in Southern California yards. But it's not what Noel is interested in.
Turns out that wetland plants that have wet feet, either like this or even fully submerged, they make a lot of suberin, particularly in their roots.
And suberin has the Salk team's attention. Suberin is a waxy layer covering small root structures. It helps cattails regulate water. They can block the salt water and allow fresh water in. Michael says the suberin-covered appendages are full of carbon molecules.
Plants are naturally carbon-accumulating machines, right? They suck carbon dioxide out of the air. All this right here is, all this biomass is basically just carbon.
And the carbon molecules in suberin don't break down when the plant dies. Noel says the carbon lingers in the mucky sediment.
You can almost see it. It's very dark and black, so it's full of carbon. In fact, I bet if you dug down, up to 10 feet below this, depending on how long this existed, it would be a huge amount of carbon that's stored.
Noel and Michael have sequenced the cattail genome, and they hope to transfer that plant's ability to make suberin into crop plants like corn and sorghum.
With these new gene editing technologies, we really think we're going to be able to go into these crop plants and tweak them to make them more like typha, and so the roots will have more of this substance.
The impact could be huge. Crop plants with the modified roots could pull as much as a quarter of the planet's excess carbon out of the air. That's enough to have a real impact on climate change. This is a key part of the Salk Institute's Harnessing Plants initiative, and Michael says cattails, or typha, have other traits that could make plants more resilient.
Each cattail makes 300,000 plus seeds. And if you've ever seen a cattail release its seeds, it looks like snow. And all of those seeds have the potential to be a new stand of typha.
But the habitat that is so efficient at storing carbon has been under assault for decades. Darren Smith is a senior environmental scientist with the California State Parks. He says urbanization has eliminated 90% of the state's coastal wetlands.
There's been a big change with people. I think wetlands were something almost like an oasis early on in California, where you just didn't run into fresh water very often.
And those same wetlands that are giving researchers hope about slowing climate change are under a lot of stress. Smith says people are making it hard for the habitat to adapt.
We built right up to them. We built the watersheds, and we built right up to the edges of them. And so for them to do what they do, to retreat, or for the water to back up and form new vegetated wetlands further upstream, there's just got to be the space to do it.
Researchers say giving the habitat space allows scientists extra time to find other plant traits that could play a role in reducing the speed of climate change. Erik Anderson, KPBS News.